Self-driving lawnmower, self-replicating robot in progress. So my Arduino is programmed with a little program that every 2 seconds it turns on or off one of the drive tires. See, that's a drive tire. This little motor spins the drive tire. 12 volts comes in from the battery here. This laptop doesn't need to be here. I'm going to go out and get myself a cell phone to be able to get out to USB-B just to power the Arduino Uno. To find some way of powering this Arduino Uno, I don't feel like mounting my laptop. It's just something I don't feel like doing, right? So it's pretty. Every 2 seconds, turns one on, turns one on. So actually what would happen here, if I put this out in the yard, it would drive forward for 2 seconds, drive a little spin for 2 seconds, drive the spin the other direction a little bit, then it'll drive that direction, and it'll spin the other direction. So it's not doing a circle. It's doing like a chicane. Like it goes this way, and then this way, and then this way, and this way, right? And this is just to test out the whole mechanics of it. The paper plates and everything is screwed down to keep the wire retention here. This is basically a junkyard thing, but it's going to be, it looks all junky, but this is how we make robots as prototypes. You just whatever you got, you slap together mechanical engineering. The real fun is in the computer science part of it. So I have vision. I'll put a basketball on top of this, and it'll know where it is in my yard, XY position. And after a little bit, it drives forward a little bit, and it knows another XY position. Now it knows what direction you're traveling in. And you can course direct it so it goes around your lawn and avoids obstacles. Bingo bango. This is the proper way of making robots, not that stupid stepper motor, not the servo stuff. NVIDIA took this technology, I call it local positioning system optical navigation. But since the camera doesn't even have to be on the robot anymore, you can self-replicate these things because all you have to do is drag metal to a smelter, which is basically a pit. You have this robot drag thing into a pit, motor drag metal into a pit or soil with metal in it, and it'll make ingot. You take that ingot out, refine it, make it a better ingot, slap it through an extruder, you got wire. Insulate it somehow. There's numerous ways of insulating it, and then you wind it. Now you have an electric motor. And then what happens, you have the robot take the electric motor and some ingots to go into some molds, and bingo bango, the robot just made another copy of itself, right? That's where we're going to, but in the interim, we're going to have the robot drive around it and mow the grass. And before we have it optical detect, which is really easy to do, believe it, it's really easy to do, we're going to have it just drive around, not the chicane. See, look at this. Imagine if every time that light's on, this wheel's spinning, right? This wheel's spinning every time that light's on. Because that's it's called a MOSFET. This 5 volt allows 12 volt to pass through. These things, MOSFET's only $2. These motors were $10, so that's $25, and the electric motor, the radiator fan at the bottom was $10. Total cost of the robot, not counting the Arduino, not counting the battery, is $10 for motor, $2 for MOSFET. $2 for MOSFET will make it $5. It's up to $15. Another electric motor, $15. Now we're up to $25 and $35 electric lawnmower that's fully automated. What I'm going to do is see. We're going to go through this real fast before. So every time a light's on, the motor's on. So both these when both lights are on, both of them are turning, basically going forward. Now if one's off, this one's turning, so it's going this direction, right? Now it's going forward. Now it's going this direction. Now it's going forward. Now it's going that direction. Or that direction. Wait, hold on. That's on. So it's this. We go that way. So whatever it's going this direction. And then this go, and then it goes this direction, right? So and then it goes. So we're chicaning, right? We're going left, straight, and then we go right, and then we go straight, then we go back left, we go straight, and we go right, and then we go straight. Like so. It's chicaning, and I want to make it do turns. If it does turns, if it almost comes back to the same position. Okay, this is before I do the optical recognition. Believe it or not, optical recognition is easy. The hard part is internet transfer of screenshots via the camera and mounting the camera to the side of the house. And it's not really that hard. I've done this stuff all the time. So just assume I have a self-replicating. Just assume I have an automated lawnmower going. But before I have the automated lawnmower, probably today, I'm going to have it just driving in circles. If the lawnmower drives in circles more or less in the thing, let it do a couple of circles, and then you reset it manually, and then you hit it, go again. And what happens is your grass is basically mowing itself with very limited interaction. And that's the plan for today. But I got to get going, show the boss this type of stuff.